Hello friends, welcome to video practical series of the soft computing. So now here we can demonstrate that how to perform the program for a fuzzy composition using a max min method. So we can write here a program for the max min composition. So whenever we write a Scilab program, so then we require these two commands: CLC for clearing the command window contents and clear for the variable browser. So for this program we required two fuzzy relations, that R and S. So we have to enter that the two fuzzy relations, that the R and S, so from the user. So first we required that the R is equal to input, we have to take it from the user, input, enter the first fuzzy relation or relational matrix. So second, S is equal to input, enter the second fuzzy relational matrix. So now friends, we are not entering here a size of the fuzzy relational matrices. So first we need to calculate the size of the fuzzy relational matrix. Suppose M and N is the size of the entered fuzzy relational, that is a size of R, that whatever you are entered that R set, so that M rows and the N columns will present in the R fuzzy set, R fuzzy relation. And then similarly X comma Y is the size of the second fuzzy, that X is equal to the size of the second fuzzy relation, that S. Okay, so that we are going to enter in the S fuzzy set. So now, so what we discussed from in this fuzzy relation, that R and S fuzzy relation, when this composition will present. So that R is the size is that 2 by 2 and S is having the size 2 by 3. So that means the composition will present the row by column. The first row of this fuzzy set composite with the first column of the second fuzzy set. So when it is possible, rows of the first fuzzy set are equal to the column of that second fuzzy set, then and then only the fuzzy composition will possible. If here the Y contains the Y1, Y2, Y3 data members and only S contains the two data members, then it is not possible. So we have to consider that the row, the column of the first fuzzy set column, that is Y1, Y2, is similar to rows of second fuzzy set. So then and then only the composition will possible. So that point we have to consider in a program. So that means if the N, okay, suppose that N is the number of columns are present and the number of rows are present in the second fuzzy set, that S. So then, and the next we have to enter we have to implement for I is equal to 1 to M and for J is equal to 1 to Y. Okay, so 1 to M number of rows and number of columns of the two resultant fuzzy set, okay, that fuzzy composition. Now, so we have to first we have to create one vector in that we can store the rows of the fuzzy set. So C is equal to R relational, that all the rows we have to first store in the C variable. Okay, so now C is a one vector in all the rows will present. Next, D is equal to the columns of that row. We have to perform the operated by a row by column. The columns of that, the second, that the fuzzy set, that S fuzzy relational. So now here, whatever the D is obtained, that D will be in a column vector format. Okay, so because we are the entering the column values in that the D variable. Suppose that we will create a one variable, that F, and in that we will calculate the transpose of that F. So then we will get all the rows the column, but it in a row format, in a row vector format. So that's for purpose we applied here a transpose, that transpose of that the D vector. Okay, so here we can calculate that the F vector, which is a transpose of that the D vector. So now we have to find the minimum values. That Q will be a minimum in between that these two values, C and F. C and F, we have to find a minimum values, and from this minimum the one maximum value will present in that the resultant matrix, that the H. Okay, Hij will be a resultant matrix is present. Hij is equal to that the maximum value in between that the Q value. Okay, so one value will present. So then in that way we can find a max value. So here a end for the inner for, then outer for. So now, so we have to display that a resultant matrix, that H, and this is a fuzzy relational between the two matrices. Fuzzy relation between two given relation matrices. So this is possible when that n is equal to x. Okay, so if this is not present, if the columns of the first matrix is not equal to that the rows of the second matrix, so then we have to display the one error message, else display fuzzy composition is not possible. Fuzzy composition is not possible. Okay, so this is the end statement of that the if. Okay, so in that way we can write the program. Okay, so first we have to need to enter the two that the fuzzy sets, that R and S, that is nothing but the fuzzy relations. Find the size of that the fuzzy relation sets, that whatever you have entered, and then find that the rows of that, columns of that the first fuzzy set is equal to the rows of the second fuzzy set. If it is equal, then and only we can find this composition result, else if it is not present, then we have to display that the composition is not possible. So this logic is very simple. We have to find the resultant matrix, that I and J rows and columns 1 to M first rows are present, and 1 to Y the columns will present in that the resultant matrix, that M and Y. So we have to find the C, that one vector, in that all the rows of that the first fuzzy set is present, that in that D all the columns, because we have to compare row by column in from the two given fuzzy relational sets, that R and S. Why this transpose is required? Transpose is required because of only that the D calculates in a column way, so it creates a column vector. So we need to compare with the C for the minimum values for this function for the line number 14. So therefore comparison will present in the same size of that the vectors. So therefore we need to transpose that the D vector and store that result in a F vector. So compare that the C and F with the minimum inbuilt function, we will get a minimum values, and that find the maximum value for that the Q. So H will be a maximum will present in that. So that in that way we can apply the first mean and then max, that is nothing but the max min composition of these two fuzzy relation. So save this program and execute it. So enter the first relational matrix. So relational matrix, how to enter? We have to use a square bracket. So what is the first value is present? 0.7, 0.5. So first 0.7 comma 0.5. The first row ends here. So we have to use a semicolon. What is the second row is present? 0.8, 0.4. 0.8 and comma 0.4. This is the second row of that, the first relational. The second relational matrix, what is the second relational matrix? Elements 0.9, 0.6, 0.5. 0.9 comma 0.6 comma 0.5. First row ends here. The second row 0.1, 7 and 5. Okay, 0.1, 0.1, 0.7 comma 0.5. So this is the fuzzy relational matrix is present. Composite relational matrix in between these two matrices. 0.765. So what is the result? 0.765. Okay, for this fuzzy relational matrix, and second is 0.865. 0.865. So in that way we can perform the max mean composition of a given to any relational matrices, fuzzy relational matrices. Okay, so this is the program of that fuzzy relational matrix. Okay. Thank you.